Hello and welcome, ladies and gentlemen, to the third webinar of the series about the new GOM software version V8 SR1. My name is Jan Franke and I have Dirk Peters next to me for the question and answer section. If you have any questions, use the Q&A section and Dirk will answer them immediately. This webinar will be recorded, so you can view the content again or share it with other people in your organization. We will show you how and where you can watch this webinar again, and also where you will find additional information at the end of this webinar. Today's topic is the Virtual Measuring Room, or VMR for short. First, we will introduce extended possibilities for VMR configurations. Then we are going to show you new options to generate positions automatically. We'll talk about how to copy and transfer measurements. We'll show you improvements for measuring the top and bottom of parts. We have an improved update behavior of the path when CAD or VMR data are replaced. And we will show you how to reuse measurement series before we also show you the new Kiosk interface. Let us start with the first topic, extended possibilities for VMR configurations. With the introduction of our ATOS ScanBox 7 and 8 series, we improved our concept for the VMR. Our goal was to reduce the number of needed project templates, and by doing so, simplifying the workflow. This was achieved by using only one VMR per measuring cell. A VMR now supports multiple working areas and multiple robots. All components of the VMR are predefined by the VMR creator. The working areas are visible in the creation process, highlighted in red. The picture on the top shows the working area of the rotation table. The other picture shows the working area of the linear axis. A VMR also supports multiple measuring volumes. The measuring volumes with its corresponding calibration series are predefined by the VMR creator. Since the ATOS ScanBox Series 7 and 8 feature 3 calibration panels visible in the top picture, changing the measuring volume is easy. A VMR now supports multiple robots. One example is the upcoming ATOS ScanBox Series 8, shown in the picture. All new enhancements are usable in doubled robot cells apart the ATOS ScanBox series. A VMR can have different measuring setups. The measuring setup itself is now a central element in the sub-explorer. The measuring setup includes a defined working area, a measuring volume defined by the sensor configuration, the position of the cut data, and setup instructions, also a new feature. There is an intended limitation in the VMR. A measuring project can have only one link point and one measuring object. Let's have a look at the new software. Here you see our new ScanBox Series 7. You see the rotation table area and the linear axis working area. You can also see the 3 different calibration panels. The corresponding calibration series are found in the sub-explorer under the System VMR Measurement series. Now all you have to do to start working with the ScanBox is to create a measuring setup. You can do so by going to the toolbar and click on the first symbol. This is the Create Measuring dialog. You can choose a name, and most importantly, you have to choose a working area. We have 2 working areas predefined. You see that now in the 3D view, highlighted in red, the rotation table plate area. And when I go to the working area linear axis, you notice that the gate will close, and it will open again when I switch back to the rotation table plate. Next up is the sensor configuration. In this case, we have 3 predefined sensor configurations. We'll choose the first one, and now the position cut data is ready to be positioned. Another new thing is the instructions for measuring setup. Here's a new dialog in which you can include a picture, either the 3D view, or you can load another picture, and you can also include some text here in this text box. This instruction setup will be triggered when you change from one measuring setup to another measuring setup. We'll not show that now, but you'll see that later when I talked about the Kiosk mode. Now we have the measuring setup as a central new element in our sub-explorer. Like other elements, you can edit it by clicking the right mouse button and choose Edit Creation Parameters. Let's say we want to choose another sensor. All done in an easy way. I mentioned the limitation of the VMR, that you can only have one measuring project per template project. And I'm going to show to you that now I will create a new measuring setup with a different working area. That will trigger a violation, and you'll see that indicated by the red no entry sign. But it is easily reversible by just deleting the new measuring setup. And if you want to change or introduce a new measuring object to the VMR, just do so by editing the measuring setup or creating a new measurement template. This is the new unified and easy-to-use teaching concept that also applies to all the other ATOS ScanWorks series. Let's go back to our presentation. In the V8 SR1, it is still possible to change the collision distance of the cut data within the VMR. Additionally, the VMR user is now able to change certain settings to avoid movement errors by activating the robot brakes or adjusting the delay before the measurement. That was a wish of our customers, and we delivered. Just click with the right mouse button on the VMR in the Overview Explorer and choose Edit Creation Parameters. Another change in the software makes the Exclude from Collision check function unnecessary. Now we have a working area for each rotation table plate and linear axis. In general, the VMR creator decides which objects are collision relevant. But don't worry, all old setups are still supported. Due to the concept of one VMR per measuring cell, the calibration series is now independent from the measuring setup and can be used for multiple working areas. When a calibration series is used for a new working area with a new measuring object, the software still performs a collision check each time. The next topic is teaching the new ATOS ScanWorks series. In the new ATOS ScanWorks series, you will still have the same possibilities at hand when teaching, and this teaching will include the use of Shift and the left mouse button to position the sensor, the automatic intermediate positions inserted by the software, and the functions to optimize the path with or without resorting. Plus, you will have an exciting new enhancement of the Shift and left mouse button positioning, the so-called two-stage computation. The two-stage computation helps us to find better measurement positions. If the clicked 3D point is not reachable, the software calculates if it is possible to move the sensor 1/3 closer to the optimum working distance or 1/3 away from it. This alone helps to create good data. And if this doesn't work, the software calculates if it is possible to tilt the sensor about plus or minus 15 degrees in any direction to the clicked 3D point. But see for yourself in the next live demo. Here we see one of the larger new ScanBox series, the Series 8, with 2 linear axes and 2 robots. In the Sub-Explorer, we already created two measuring setups, one for the left axis and one for the right axis. The left one is already active, so we have direct access to the two axes, and we could change the robot. Now we want to create a measurement series, and we're going to start by just creating a new measurement position, and we're simply going to position the sensor by moving the shift and left mouse button position. The software will calculate the path, and will also, as soon as I press the space button, insert the measurement position, and it will insert a home position. Let's insert another position here at the back of the car, again with the shift and left mouse button function. To insert the measurement position, I will press space again, and that was easy so far. Let's make it a little bit harder for the software and choose a position here in the front of the car, and now it has to go around the car to insert that position. And we will see that the computation takes a little longer because it will check the path for collisions, and it will automatically insert an intermediate position seen here in the measurement series. Now that is great. You don't have to do that anymore, and the software will automatically compute that for you. Let's see that again here in the house wheeling. Insert another position. And again, the computer inserts an intermediate position and the position. We will finish this measurement series with inserting a home position using the iTeach. The computer will go back to its home position, and we finished our measurement series. Let's look at the photogrammetry. We'll first have to define the series as active, and as soon as we do so, we can see that the measuring volume will change as soon as we can see it in 3D view. I will click on another position, you see the large measurement volume, and in this case you can see a typical problem that we run into with large photogrammetry volumes. It is difficult to get the right measurement positions at the top of a large CAD model. But our two-stage computation solution is at work right now. The sensor is a little closer to the object, and even though it does not have the optimal distance to the center of the measuring volume, will still receive good data. Let me just press the space button to demonstrate that, and it will insert it into the measurement series. So far, so good. To sum it up, I think it is safe to say that the teaching of the ATOS Scanbox hasn't changed that much to before, but it now makes teaching even easier. Let's continue with our presentation. When you teach an ATOS Scanbox, you sometimes need to go from one position to another. The move to position function is very helpful to move quickly to certain positions. In the V8, this function always moved the robot along the path one position after another. The improve function moves the robot directly to a selected position, and if necessary, it will insert intermediate positions automatically. But since it moves along a non-validated path, it will only move slowly. And if you want to use a rotation table area, you've already heard that you need a specific working area. And that working area has a specific home position. And in order to move the sensor to that home position and back to its original position, you need a home path. And the home path is already defined, and all you need to do is to create it. You will then find it in the sub-explorer attached to the system VMR measurement series and is ready to use. The next challenge is also, the next topic is also a challenging one, the automatic exposure time computation. And to set the correct exposure time, meaning balancing quality against duration, can be challenging, especially if several exposure times are necessary or the measurement conditions are bad. Our solution for these problems is the automatic exposure time computation, which determines the optimum exposure times automatically. With only a few clicks, you will receive automatically set, ready-to-use exposure times. The software offers different functions for different applications. Spot metering was designed for the measuring of simple objects with a low dynamic of gray values that only need one exposure time. The matrix metering was designed for more complex objects with a higher dynamic of gray values when multiple exposure times are necessary. The default setting within the VMR is the cut metering. This function uses a cut and the virtual camera image to mask all areas outside of the cut and was designed for complex objects with fixtures, like airfoils. The cut metering does not need exposure time settings. To learn more about the automatic exposure time computation, we will tell you where you can find a more detailed video at the end of this webinar. Let us start with the next topic, the automatic position computation. In the V8, it was already possible to automatically create measurement positions for gray value features, surface points, and hemmed edge points. To optimize the path was also possible. For the V8 SR1, we focused on sheet metal, airfoil, and cut. Now we support new elements for sheet metal applications. The new elements are hemmed edge curves, projected offset sections, flush and gap curves, and design lines. With that, we completely covered the position generation for sheet metal application. Only when we know what we want to measure, we can generate positions for the measuring principles. Regarding airfoil applications, these are profile mean line, profile edge points, and profile edge circles. The distance between the points on the sections depend on curvature and measuring volume. In the picture, you see that the point density around the leading and trailing edge is higher. At the concave and the convex side of the airfoil section, the point density is decreased. The software aligns the sensor automatically in order to ensure that the fringes are running perpendicular towards the edges of the airfoil. The sensor is also tilted vertically out of the normal direction to avoid reflections on the edges. In order to ensure that all areas are definitely captured, the software creates redundant measurement positions for every inspection point. The software does this entirely automatically based on your requirements. We have measured an industrial gas turbine blade to give you an example. 21 measurement positions were needed to digitize the blade manually. The automatic position generation was able to do it with just 24 measurements. The result is almost equal in number of positions, but was achieved with much less work. We concentrated on measuring principles for different applications, but another focus had to be set on what we measure with our sensors, because almost every report contains a color comparison. That means we need to generate sensor positions for surface measurements too. The creation of positions happens in 2 rounds. In the first one, the software creates measurements for all of the supported elements. In the second round, the software creates measurements for the surface, even for the surface that already has been measured with the positions generated in the first round. Let's walk through the workflow. First, we need to create the measurement positions. The software creates measurement positions based on the software comparison and also checks all paths for collisions. Then, if necessary, we'll optimize the path. And finally, we will create a color comparison. One big advantage of this method is that the measurement positions from the CAD will help us to fill the gaps for better surface comparison. But please keep in mind that maybe some small features will probably not be measured and that a few more inspection elements might be necessary. Let's have a look at the position generation in action. Here we have a flywheel in one of our small ATOS scan boxes. We only have a measuring setup active now and no measurement series. But we've already created a surface comparison, and now we're ready to use the function create measurement positions. Just one click will automatically create the positions we need to capture the flywheel. And this function will also automatically create a measurement series, so we don't have to do that anymore. The software computes the measurement positions and will also check the path for collisions. The result is a measurement series with 8 measurement positions. We do have a collision here, but that's not a big problem. We can just go to optimize path and start it. The software will insert a new intermediate position, and the path is now collision-free. Now let's have a closer look at the flywheel. I will show it to you exclusively by pressing the E button after I select the flywheel. You see the nice coverage, but on the downside, on the bottom side, you'll see still a few patches, few gaps that the software didn't capture. But that is not a big problem. You can just insert a few inspection elements before running the function, and that will get you a nice coverage of the whole flywheel. So in conclusion, we can say that it's not a one-click solution yet, but we can also say that the position generation has been expanded to even more application, and though the computation time is sometimes a little longer, it is still pretty amazing considering how little the user has to do on its own. Let's continue with our presentation. The next topic is general enhancements. The new copy and transform measurement functions simplify the creation of measurement series for the measurement of rotationally and axially symmetrical parts. The functions are easy to use as they are similar to other functions like the copy and cluster function. Another goal was to replace the system scripts, mirror position, and transform positions. Of course, the creation of photogrammetry measurement is also supported by these new functions. The copy and rotate measurement function is especially helpful in that regard. Another enhancement was made regarding the measuring of the top and bottom of an object. Now all you have to do is to create a new measuring setup, flip over the cut, and copy and paste the measuring series in the new setup, and you're good to go. You will notice the path of the measuring series will stay green since it was already validated in reality. Let's go to the next live demo. I will show you the new functions of the copy and transform functions. You see in the scan box, we have a trunklet. We've also created a measuring setup already with a photogrammetry series. We have 5 measurement positions in that series, and that is not enough to capture the whole trunklet. So we need to copy these measurement positions. We can do so by going to Acquisition in the menu, to Automation, and Copy and Transform Measurements. Here we see our 3 functions: copy and rotate, copy and translate, and copy and mirror. Like I said, for this special case, we'll use the copy and rotate function. After I've selected the measurement series, we will see the first results in the 3D view. Since the number of copies is still 1, we only have 1 copy on the other side of the already 5 existing measurement positions. But when we increase this number, you can clearly see in the 3D view the new measurement positions. The angle will be adjusted by the software automatically. And to insert the copies, we have different options, but this is the ideal option for this function. The result is shown in 3D view and also in the Sub-Explorer. You see all these new measurement positions. And in the 3D view, you can see this really nice bell-shaped cluster of measurement positions. And in conclusion, the new copy and transform functions are a nice way to multiply and reuse measurement positions to create whole measurement series with less or little effort. Let's go to our next live demonstration. You'll see our scan box, and we already have a measuring object lying on the rotation table with the corresponding measurement series. You can see that here. The path is already collision-free and was validated in reality. And now we want to measure the bottom side of this measuring object. And for that, we have to simply create a new measuring setup. We can name it bottom, it was already in the system. And we want to say that we need to click independent to position the cut data. And in 3D view, we can use these handles to just flip the object around. You can cheat a little and use this wonderful button down here in this dialog, the automatic transformation. Create the new measuring setup, and you see that the measurement series stays at the same position and does not change. Now let's take this measurement series and copy it, and now we're going to insert it into the new measuring setup. And we're already finished. The measurement series is now in the new measuring setup and is ready to go. It was already validated, and we don't need to validate it again. We can say that this is a really nice improvement, just helps us to measure the bottom and the top of objects in a much easier and faster way. Let's go back to our presentation. The next topic is template management. The only thing that is constant is change. You've probably heard that. And so it can happen in a production process that the CAD model or the VMR changes too. This will require a change in an update of the CAD or VMR in the VMR project. That also includes a revalidation of the path. For the VMR user, that usually meant a lot of work, especially if the CAD or VMR was used in multiple templates. For the V8 SR1, we improved this update behavior. Now, after a change of the CAD or the VMR, the paths are still valid, as long as no collisions occur. If a collision does occur, only the positions with the collisions need revalidation. We're going to see that in the next live demo. Again, we have a scan box, we have our measuring object, the trunklet, we have a measuring setup in the sub-explorer with different measurement series. The path is validated and collision-free. And let's see what happens. I'm sorry, I need another trunklet. Now let's see what happens when we import a new trunklet. You can see in the Overview Explorer that we have two trunklets now, and the path is still valid and does not need any change from the user side. But what happens if we change the VMR? I will import another VMR element. For this example, we've created a little cube to make it visible. And this time, we do have two collisions in our measurement series. So the collision computation or detection does work. To get rid of the collisions, we can just simply click the measurement positions and optimize the path with resorting. Now we have just 3 measurement positions in the whole of our measurement series that needs to be validated in reality again. But with just a few clicks, the whole of the measurement series can be validated again and be reused. To sum it up, I think that this small improvement has a significant impact and will hopefully make your daily work even easier. Another topic of the template management is the reuse of measurement series. For example, in some cases, we have a project where we know that for the identical CAD part, we already have a photogrammetry series in another project. It is now possible to copy this series and to import it into the new project. I'm going to show you that behavior in the next live demonstration. That looks quite familiar, doesn't it? Our scan box, a trunklet on a fixture. We already have a measuring setup and a scan series. All validated, green, collision free. But now the user needs to create a new photogrammetry measurement series. But he remembers that he has an old measurement series lying around somewhere. And he can just take that photogrammetry series and import it into the VMR project. We've imported it, and all we need to do is to cut out the photogrammetry series and import it into the new measuring setup. Easy as that. We can define it as active. You see the change of measurement volume, and we can start using the measurement series and finishing our photogrammetry series even faster. Again, another small improvement that will make the reuse of already finished measurement series that much easier. Up next is the simplification of Kiosk interface adaptations. The question for us was where the customer required changes, and to find a solution we asked for custom patches files and analyzed them. One of the top 3 requirements was a user guidance. And the result is the measuring setup instructions that answers questions like, how has a real setup to look like? Which clamp needs to be closed and in which order? The measuring setup instructions is now an element in the Explorer. We talked about how to create such a measuring setup at the beginning of this presentation. The measuring setup can contain an image or text to show instructions, like mentioned before. The second requirement was a customized start dialog. Almost every customer needs specific keywords for his workflow. Therefore, an adaptation was required. That is now possible with the custom patch generator script. And the third requirement was to customize and adjust the export of results. This was also realized with the custom patch generator script. In the next live demo, I will show you how the custom patch generator script works. Now this is the project we've just finished, and would like to use this later with the kiosk mode. But usually before we can start the kiosk, we need to run the setup script. To find the setup script, go to Scripting, Script Choice, Kiosk Interface, Setup, and Setup Script. In the setup, we would need to define the public folder and a folder for the results. We have already prepared that, so we will skip this part and focus on the new custom patch generator script. In this dialog, it is possible to customize keywords and the export format. We'll start with the keywords. First, we have to confirm the patch start dialog checkbox. And now we can copy the keywords from our project. On the left side, you see a list of all the keywords in the project. Down here, we can click to add a few keywords. We just go with this one, the chassis number, and the sort number. And the next one will be chassis number. On the right side, you see the chosen keywords. If you've chosen too many or this requirement will change, you can always delete keywords by choosing the keywords from this list. Now the chosen keywords appear in this dialog. You could later add more keywords, and we can edit the keywords. We don't want this to show in the kiosk interface, so we're going to make that a little prettier, like this, and edit the next one. chassis number. And this time, we're going to say that this keyword is optional. We'll see later what that means. We can also confirm the patch plausibility check of dialog input. This check allows us to limit the input into the Kiosk interface to specific characters or numbers. To customize the exports, we have to confirm this box here. We can also keep the original exports and add our own exports. In this field, we can choose the format of the export. You already maybe know some of the export formats. You can also find them in the software under File and Exports. You see we have almost the same formats ready to use in the script. And in some cases, you can also customize the length of the export and the angle. You can use the standard export folder, or you can create a new custom export folder. With the keywords, you can also always add more export formats later on, and you can of course delete the exports. Now that we've done this, we need to start the kiosk. We have our user, John, and we can enter a serial number. Now we need to choose our template. And since we already have only one template, the software will automatically choose that one template we have lying around. We'll enter a chassis number. And we could already start the Kiosk interface because the sort number is not required. Remember, we enabled the optional box. So this is not mandatory, but we'll still enter a sort number. And now we can start the Kiosk interface, or the kiosk. Let's go back to our presentation, but let me just say this last bit. In general, the custom patch generator script is quite easy to handle and will help you to customize the kiosk for your needs. We have almost reached the end of the webinar. There are also additional informations we'd like to mention. You can download a beta version of the V8 SR1 already. GOM has launched the Open Beta program in order to give you the opportunity to try out new functions and enhancements without affecting your daily business. The V8 SR1 will run with the current V8 license, so there's no need to update your license if you are on V8. Please find more information and the software packages under the following path: support.gom.com, download software, overview, GOM software V8 SR1. The final release is planned in mid-January 2016. As mentioned at the beginning, this webinar was recorded. You will find the video for download in the support area and also on the GOM Metrology YouTube channel. In addition, we have produced video tutorials for the new functions. We are also available on YouTube and in the GOM Error Service area for download. We could not cover everything in this webinar, so there are videos for additional functions available. You can find a detailed list of new features in the Direct Help. We also implemented the links to the video tutorials for the new functions. The next webinar in our series about the new version V8 SR1 is airfoil inspection and will take place on December 17th. This was the webinar Virtual Measuring Room. We will stay online for a while to answer your questions in the Q&A section. thank you very much for your attention. We hope you enjoyed it. Have a nice day and auf Wiedersehen.